Hello everybody, this video is for the topic of Mohr circle, which is just a graphical way of determining the principal stresses. Principal stresses are what? Sigma 1 and sigma 2, and also tau max, maximum shear stress. Okay, so the way we start this is by looking at the transformation equations. You guys recall that transformation means that you just go to a different plane by angle theta. So remember sigma x prime and tau xy prime are given based on the equations that you see here. All right, so now what we want to do is to modify these two equations to show that actually this will turn into an equation of a circle, which I've shown you here, down here. So we'll get to that in a minute. So how do we do this? First of all, I'm going to call this sigma x plus sigma y over 2 to be sigma average. So sigma average, obviously the average of the two normal stresses. And then, so what I'm going to do, I'm going to actually bring this sigma average to this side of the equation. So equation 1 is modified now to this. Very simple modification, just bring this sigma average to the left-hand side. The right-hand side, basically these two terms remain as where they are, these two. Second equation, I didn't do anything, I just made this a minus 0, which is basically doing nothing. And then these two terms, they remain the same as before. Now, the way we come up with the equation of the circle is that we square both sides of each equation, right? So if you do that, square both sides of the equation and then add them up, add these two up, right? What will happen is you get sigma x prime minus tau average, right? Plus, sorry, this is a plus sign, not minus sign. Plus tau xy prime minus 0, which is this guy, squared. So now add the right-hand side. Now, the way it works out, and you should write this on a piece of paper and try it for yourself. When you square this, it's like saying a plus b squared, right? What is a plus b squared? Is a squared plus b squared minus 2ab. So in a way, this is kind of like a, even though one is cosine 2 theta, one is sine 2 theta. But remember, when you factor that out, you get sine squared 2 theta plus cosine squared 2 theta is equal to 1. So you end up getting just sigma x minus sigma y over 2 squared. And then the same thing happens here. And then the 2ab term, since this is a negative, I'm sorry, this is plus 2ab. And then if it's a minus b becomes minus 2ab. Okay, so the 2ab term is going to get cancelled. Therefore, you get this term here. Now, let's compare this, and let me erase this here so you don't really have to worry about these things. Okay, so now, what is the equation of a circle? You guys know equation of a circle. The general equation is x squared plus y squared equal r squared. But if that is for the center of the circle being at 0, 0. If the center is at x1 and y1, then basically the equation becomes x minus x1 squared plus y minus y1 squared equal r squared, right? So here, compare this equation with equation of a circle where the center is actually, the y coordinate of the center is 0. So this actually becomes the r squared, the right-hand side, and this becomes your x1, the x coordinate of the center, and the y coordinate of the center is 0. So basically, center has a coordinate of sigma average and 0. Okay, so far so good. So this represents the equation of a circle, this guy. All right, so how do we go about drawing this circle? Let's go to the next page. All right, so let's start with our stress element, guys. So remember, a typical stress element, you get sigma x, sigma y, tau xy. And in this case, actually, I showed both sigma x and sigma y to be positive and to be in tension. And tau xy, actually, this is a positive tau xy. I just want to remind you that in the past, when we talked about principal stresses, we calculate theta 1. Remember, tangent to theta 1 was what? Tangent to theta 1 was, I believe it was tau xy divided by sigma x minus sigma y over 2. Right? And then you look at a different plane where the principal stresses are acting, right? And then 45 degrees to that would be the plane of the maximum shear stress, right? And then you also have the average stress acting there. So let's see how we can actually plot this Mohr circle, and then, so this is our Mohr circle, right? That's shown here. And then we can go about showing you where these principal stresses are and where tau max is on the circle. All right, so this is the way we do a Mohr circle. First, you need coordinate of one point. Usually you pick this point here on this plane, right? Point A has the coordinate of sigma x tau xy, whatever they are, positive, negative, you put them in here. Also, from the previous page, you see that C has what? The center of the circle has coordinates of sigma average and 0. So here, your center with the coordinate of sigma average, right? So this is sigma average here, right? And 0. And then this is the coordinates of point A. Now, one thing I have to mention is that in your textbook, actually, sigma axis is kind of like your horizontal axis, and tau axis, I'm taking positive to be downward, by the way, and I think this is a better approach than what the textbook does, even though it turns out to be the same thing, basically. But just follow this in terms of the sign and directions. Okay, so locate point A, connect A to C, and that establishes a radius, and then draw your circle as I have done here earlier. By the way, I used the top of a can, kind of small can, to draw this circle. You have to become creative these days with the your drawing. I didn't want to draw a very crooked, circle for you. Anyways, so now look, this point A. In order for this point A to get to the principal plane, which is right here, you have to go a theta 1 or theta p angle, right? Counterclockwise. So you see, if you go counterclockwise, you get to what? Your principal stress. By the way, principal stresses are what? The maximum normal stresses. So maximum normal stresses obviously has to be on the sigma axis, right? Because this is the maximum. And the minimum is going to be right here. Now, notice that the difference between, so remember that everything on the element is based on the theta angle. When you go to the circle, the Mohr circle, everything is 2 theta. Okay? So remember, the transformation equations were based in the 2 theta angle, right? That's why they changed to 2 theta angles, so that they could eventually give us the equation of a circle, actually. That was the reason. Anyways, look, the difference between theta plane, theta 1 plane and theta 2 plane is what? 90 degrees, right? But look, on the Mohr circle is what? 180 degrees, double that. So we get to what? The sigma 2 plane. Here in this case, that's in compression because it's on the negative side. Okay, so this is a compressive one, as shown in the picture here, and this is a tensile one, right? Now, in general situation, both could be compressive, both could be tensile, or one in this case, like this case, would be compressive, and one could be in tension. Anyways, so basically, you see, where is now the maximum, the plane of maximum shear stress? 45 degrees from here. 45 degrees from here would be right here. You see, 45 on the Mohr circle would be what? 90 degrees, right? So if you go 90 degrees, what are you going to get? You're going to get here. So if you call this point, for example, D, Point D is here. See that? That's the plane of maximum shear stress. And by the way, this is a negative shear stress because we are on the negative side of the axis. All right. And what's the coordinate of point D? Coordinate of point D is sigma average, right? You see that? Sigma average is the coordinate, has the same horizontal coordinate of the average stress and tau max. And look, point D, sigma average and tau max. Now, by the way, let me ask you this question. What is, if I call this point B, right? The plane of I'm sorry, not that point. I'm sorry, I don't want to confuse you. Point B actually would be here, right? Put this back here and clean this up for you. Where is this point? That's what I meant, actually, in the original stress element. Sorry, guys. Point B would be 90 degrees from what? From point A on the element, which means 180 degrees. So if you take A and rotate it 180 degrees, this would be point B. Okay? With the coordinate of sigma y actually and minus tau xy. All right, so remember that every point on the element, right, every angle, let's put it this way, in any new plane on the element corresponds to what? Corresponds to a point on the Mohr circle. But remember that everything on the Mohr circle is double angle. All right, I'm going to come back and show you an example that I've already used a couple of times for doing the transformation equation using a stress element that you've already seen a couple of times in other examples. And then hopefully that would make sense to you, when you look at the numbers and everything. Okay, as always, thank you for watching and listening.